So we'll move on to our next speaker, which is going to be Catherine Elder, talking about Einar on recent lunar volcanism.
Thanks. Can you hear me okay?
Yes, I can.
Okay, so next slide. So Ina is one of about 70 irregular Mare patches that have been discovered on the moon. Irregular Mare patches are some sort of volcanic landform, and that's about where the consensus about them ends. Crater size frequency distribution, optical maturity, and steep slopes all suggest that irregular Mare patches are very young, with crater counting suggesting that they may be less than 100 million years old. Next slide. However, this cannot be explained by existing thermal evolution models. For example, Zeeth et al. 2009 showed that a partially molten layer could be maintained in the lunar mantle until about 2 billion years ago. And at the time, the youngest volcanism that had been suggested on the moon was about 1.2 gigayears. And so they argued that with the addition of heat from the PKT, which their model did not include, and considering the uncertainty on the crater count ages, they argued that a partially molten layer 2 billion years ago was roughly consistent with the observed lunar volcanism. However, partially molten mantle only until 2 billion years ago could not explain volcanism as recently as the past 100 million years. Next slide. So one of the formation hypotheses about the irregular Mare patches is that they are highly vesicular magmatic foam, and Wilson and Head and a number of papers by Chow et al. Have suggested that the material properties of this magmatic foam might be such that they affect crater size and thus inferred ages. And so these authors have argued that the irregular Mare patches are actually comparable in age to the surrounding Mare volcanism. Next slide. However, with this highly vesicular magmatic foam, you would expect that to affect the morphology of the craters that are observed on the surfaces. And a recent paper by Basilevsky and Michael showed that the morphology of craters inside Ina are similar to those on the slopes outside of Ina. And they argued that the crater morphology was inconsistent with an ancient formation of the irregular Mare patches. Next slide. So there are significant, yeah, can you go to the next slide? Thanks. So there are significant questions remaining both about the age of Ina and also about its formation hypotheses. So we suggest two main science goals. First, is Ina an example of endogenic geologic activity on the moon within the last 100 million years? And what are the eruption dynamics or compositions that led to the unique morphology of Ina? These goals would be responsive to the decadal survey question about the workings of the solar system, and also the more specific decadal survey question about the distribution and timescales of volcanism on the inner planets, as long as you assume the moon is a planet. Next slide. These goals are also responsive to a number of the goals in the scientific context for the exploration of the moon report. And I'm not going to go through these all here now, but they're also in my abstract if you want to look at them more closely. Next slide. So to achieve these science goals, we suggest 5 science objectives, including determine the age of Ina, determine whether the properties of Ina's smooth mounds are similar to lava flows covered with regoliths seen at Apollo landing sites, pyroclastic material, or magmatic foam, determine Ina's composition and whether it is distinct from known Mare deposits, determine whether the material at Ina's smooth mounds is crystalline or amorphous, and determine the water composition and content of the smooth and uneven terrains of the irregular Mare patches. Next slide. And so to address these science objectives, we would need to land on Ina. The largest smooth mound is probably the easiest place to land and would be suitable for these objectives. There are a lot of great science objectives that you could address at Ina. To me, the most important question is it really recent volcanism? And as far as I know, the best way to conclusively resolve that debate is to do in situ geochronology or sample return. Though I will note that the uncertainty on these measurements could be quite high because the disagreement over Ina's age spans 2 orders of magnitude. So if we could conclusively show that it was anything under 1 billion years old, that would be a huge result. To address the science objectives we've outlined, you would also need a camera, a multispectral microimager, and a point spectrometer. I considered
Just
mobility
letting you know, Catherine, you
enhancing.
have 1 minute.
Okay, thanks. I considered mobility enhancing, but it depends on your science objectives. Um, And then heat flow probe would also be enhancing. Additional instruments to really nail down the composition would help as well. And ground penetrating radar could help distinguish between the different formation hypotheses of Ina, since the different formation hypotheses would lead to different subsurface structures in the smooth mounds. And that's actually all I had. So we can move on to Mark's talk about Ina.
Oh, thank you very much, Catherine.